What's up, guys? It's Dan from sagemathtutoring.com. Want to make a quick video that will help my friend with his test tomorrow, and this is based off of a review sheet that he received. So whenever I have time to help, give a little extra help, if I have time, then I like to do so by actually creating a video outlining principles of problem solving. Anyway, here is the first problem right here. Now, some of you can see we are dealing with a quadratic equation. Alright, so the idea here is to solve this problem by using the square root method. So basically what the square root method means is that you're going to want to isolate the thing that's being squared first. Alright, so at the end we want to solve for x, but in order to get there we have to first isolate this thing right here because it's the thing that's being squared right now. So as you may notice, we could get rid of this negative 8, and we could also get rid of this negative 2. It's helpful to treat this as though it was almost like negative 2x minus 8 equals negative 24, because that could serve as a potential reminder that really the first thing that you'd want to do is you would want to get rid of this negative 8 first before solving for this thing. So sometimes imagining a simple case could be helpful. So that's what we will do. We will add 8 to both sides, and we're going to end up with negative 2 times x plus 4 squared equals, that would be negative 16. And at this point, it's a matter of dividing both sides by this negative 2. That would result in x plus 4 squared equals positive 8. And then now we're ready to do the actual square rooting action of this, and that looks like using these big square root symbols. Don't forget to do the plus minus thing over here. That's a good habit to get into. And then we have x plus 4, because this square root symbol crosses out with that 2. And then we have plus minus the square root of 8. So at this point, we could actually simplify this radical 8 right here, and I'm going to trust that my student knows how to do that and would know that that radical 8 is actually 2 radical 2. And at this point we are ready to solve for x. Solving for x would mean subtracting 4 from both sides, and that would cancel. And this negative 4 cannot be combined with this positive minus 2 radical 2 because of this radical here. So radical 2 is a very famous irrational number, and if you have a radical like this, you're not going to be able to combine this with the negative 4. So we're kind of stuck with this answer where it's x equals negative 4 plus minus 2 radical 2. Now, make no mistake about it, there are two solutions to this problem. X equals negative 4 plus 2 radical 2. X also equals negative 4 minus 2 radical 2. Alright, so that is problem number 1. Let's erase some of this stuff. And once again, that is an example of using or solving by the square root method. We'll just go to a new page. So the next problem is 3 times x minus 2 squared equals 48. Similarly, we're going to want to isolate this number that's being squared. Whatever is being squared is what you want to isolate first, and the way that we would do it is by dividing both sides by 3. That of course cancels that out, and then we end up with x minus 2 squared equals, that would be 16. What, 16 times 3? Yeah, that would be 16. So then you would have to, of course, take the square root of both sides. So that looks like a big square root symbol there, and then plus minus, and then we end up with x minus 2 equals plus minus 4. That is, of course, because this square root symbol cancels with this 2 right there. So we're in this position here where we have a plus minus 4 and x minus 2. Now we're absolutely ready to solve for x by adding 2 to both sides. And then we end up with x equals 2 plus minus 4. Now this situation down here, the x equals 2 plus minus 4, notice how this second number, the number here that's next to the plus minus, unlike the problem that we just did, this 4 is a rational number that could actually be combined with the 2. But keep in mind, we've got 2 plus 4 and we've got 2 minus 4. So we actually have to take both of those into account. Obviously 2 plus 4 equals 6 and 2 minus 4 equals negative 2. So those would actually be your answers. It would be negative 2 and 6. So once again, quadratic equation featuring 2 answers. All right, the third problem is the following. We've got 4 plus x plus 1 squared plus 3 equals 27. Similarly, we're going to want to get rid of this number right here. In this case, it would be a matter of subtracting it. So we end up with 4 times x plus 1 squared equals 24. Then we're going to, similar to the last problem, divide by 4. And that would cancel this with that, leaving us finally, or at least for now, with x plus 1 squared equals 6. So that's where we're at right now, and as we've been doing, we take the square root of both sides, don't forget the plus minus, and then we end up with x plus 1 equals plus minus the square root of 6. Now, maybe upon some investigation, you would recognize that this 6 cannot be simplified, or this radical 6 cannot be simplified anymore. So we're kind of stuck with this radical 6. So what that means is you just kind of carry on as we did with the first problem by subtracting 1 from both sides. And that would cancel these, leaving us with x equals negative 1 plus minus radical 6. And it's good when you subtract a 1 from both sides and you have this plus minus number. It's better form to have a negative 1 on the left hand side. It's always better form to have the plus minus in between the two numbers, just so you know. So that's the answer to that one. Fourth problem. This is the first problem where the teacher is asking you to solve by factoring. All right, so that's sort of highlighting the fact that there are different ways of solving quadratic equations. In this case, there is an invisible coefficient of 1 right here, so we don't have to worry about things being too complicated. All you need to do is focus on this positive 32 and ask yourself, what are the factors of a positive 32 that when you add them together, they would give you a negative 12? So that's food for thought. In the meantime, while I'm thinking about that, I'm going to draw empty parentheses because I know it's going to look like that. I also know that there's going to be an x here and an x here. So when you know stuff, just draw it. When you know stuff, just write it down, just to stay in the flow with it. Once again, what are the factors of positive 32 that are such that when I add them, I get a negative 12? Well, you've got 1 times 32 is 32. You've got 2 times 16, that would give you 32, and so on. So you could go through the motions in that regard, but some of you might already be recognizing that it would indeed be a negative 8 times a positive 4. Why is that? Well, that is because a negative 8 times a positive 4 would give you a oh wait, my bad, made a mistake here, sorry guys. That would be a negative 8 times a negative 4 right there. And the reason for that is because a negative 8 times a negative 4 would give you a negative, or a positive 32, because a negative times a negative gives you a positive, and a negative 8 plus a negative 4 would give you a negative 12. So that's the idea. By now, my student definitely knows that when you see something like x minus 8, well, that just means that one of the answers is most definitely 8. And whenever you see something like x minus 4, that means that one of the answers is 4. All right, so that's the answer to that one. We've got 2x squared minus 3x minus 20 equals 0. So at this point, we have a little bit of a different situation. It's another problem where the teacher wants you to solve it by factoring. But at this point, we've got a 2 as the leading coefficient right here. Now, believe it or not, that actually makes things significantly more challenging. So, first things first, just check through the whole thing and ask yourself, is there a way to factor this 2 out and kind of get rid of it by dividing both sides by 2? Well, you would be able to factor a 2 out of the whole thing if 2 happened to be a factor of this term and also this term, but unfortunately 2 is not a factor of this term right here. It's a factor of this term, but not this term. So we're kind of stuck with this 2, which means we have to employ one of numerous tricks of the trade to solve this one. Different teachers have different ways of teaching how to do this. There are many different ways. I prefer to kind of do a factoring by grouping method, but a lot of teachers will sometimes just kind of have you draw the parentheses, set it equal to 0. In this case, we've got a 2x right here and an x. Now, that's indisputable. These are the only factors of 2x squared that would work in these positions, so that's actually very fortunate. All right. Now, what we want to do is find, kind of think of like 2 different factors of negative 20, which, by the way, could be very complicated. For example, what you want is factors of negative 20 that are such that, let's say I put one of the factors here and one of the factors here. You want it to be such that when you multiply this times this and then you add it to this times this, you're going to end up with a negative 3. All right, so I'm going to say that one more time. Imagine you had a factor here, a factor of negative 20 here, and another factor of negative 20 here. You want the factors to be such that if you were to multiply this times this and then add it to this times this, you would actually get negative 3. So once again, this times this plus this times this would equal a negative 3. All right, so that's one way of going about it. It's kind of a way that requires trial and error. There is a certain skill level and level of practice where you get the hang of it and you kind of spot it. Like, for example, I'm thinking like 4 and negative 5 are tempting to me because I think 2 times 4, well, that puts us in the 8 range, and then 5 times this, and it would be like 8 and then 5, and then I associate 5 and 8 with a difference of 3. So at a certain point, it kind of flashes in your mind what you need to do. So we're going to put a 4 right here. We're going to put a 5 right here. We know for a fact one of them has to be positive, one of them has to be negative, because it's got to be a positive times a negatives gives you a negative 20. That leads us to ask ourselves which one of these factors should be positive or negative, and it so happens that it would indeed be the 4 that should be negative and the 5 should be positive. So the reason for that is because 2 times negative 4 is a negative 8, and 5 times this invisible 1 right here is 5, and 5 plus negative 8 gives me the negative 3 that I'm looking for. All right, so that's the idea. So we have properly factored this one, and let's see what we've got here. Well, this one, my student definitely knows that what this parentheses means is that one of the answers is most definitely 4, all right, due to the same reasoning process that he employed in the last problem. This one's a little bit trickier, where you have to remember, basically, in order to get the answer, in order to figure out what x is, you actually have to sort of temporarily set what's inside the parentheses equal to 0. So here I go doing that, 2x plus 5. We're going to take this off to the side and set it equal to 0. And then we're going to solve for x. So we have subtracting 5 both sides, you end up with 2x equals negative 5, and then you would end up with dividing both sides by 2. Right, and you end up with x equals negative 5 over 2, also known as negative 2.5. All right, so we can go like that. To kiss your teacher's butt, you might want to put these answers in sort of order of least to greatest, but I'm lazy, so I'm just going to leave it there. All right, so that is that one. Looking at the next problem, we have x squared, let's see, minus 9 equals 0. Okay, well, this is a classic example of the difference between two squares, which is definitely something that at a certain point I would highly recommend anyone who is doing math to memorize. All right, so whenever you see a difference between two squares, in other words, you have some number that's a perfect square subtracting another perfect square, what you could always do is factor it thusly. All right, it's one of those famous things that, you know, when math students grow up to be adults and don't need to do this stuff anymore, it's possible that they still have nightmares about stuff like this. So anyway, the question is always going to be, well, what's the A? You know, A is the thing that's being squared right now. In this case, your A is x, right? And then the question is, well, what's your B? Well, B is the thing that's being squared over here. It might not be immediately obvious what's being squared. In fact, I would suggest rewriting this down here to get very clear what your B is. And what you would come to find is that your B, in this case, is 3. All right, because 3 squared gives you 9. All right, so we have determined what our quote-unquote A is, and we have determined what our quote-unquote B is. A is x, and B is 3 in this case. Once again, this, of course, applies to using this structure. And once you've determined what your quote-unquote A and B is, you can then do the factoring in accordance with that structure. So what we have is x plus 3 and x minus 3, where, of course, the A corresponds with the x and the B corresponds with the 3. All right? Now, at the end of the day, this equals 0, which means this equals 0. So I say, on the next line, we actually write that. Get back to somewhat like more familiar looking ground. And so what do we got? My student should definitely know this. He knows that this would be, therefore, x equals a -3 as one of the answers and a +3 as the other answer. All right, so that's how that one works. All right, moving on, we got x squared. I'm going to keep it in black. We've got x squared equals 5x plus 24. Once again, the teacher wants us to solve this by factoring, but the problem is, you may have noticed all the other problems that we've dealt with so far, they were, you know, maybe looking like something like this, where it's like equals 0, right? Where the teacher kind of wrote this nice equation with the little 0 on one side all by itself and this neatly on the other side, and then we ended up factoring it, right? Well, this one right here, they're being smart Alexes with us in the sense that we don't have it equal to 0, right? There's no 0 around here. So actually, they're trying to trick us into just like factoring it right there. First thing we got to do is set this thing equal to 0. All right, so let me get rid of this other thing. All right, and that's what we're going to do. We're going to set this thing equal to 0 right now. I'm a big fan of keeping the x squared thing positive, so my thought is, let's get rid of all this stuff so that a 0 will be on the right-hand side, and we could still have our positive x squared on the left-hand side. Clearly, that would be a matter of subtracting 5x and a 24 from both sides. And of course, we got to do it over here too, right? And we end up with x squared minus 5x minus 24 equals 0. Then we can factor. Now, once again, there's only this invisible 1 coefficient here, which means that if this is indeed factorable, it will be relatively easy compared to that other one that we did with the 2 in front, or the -2. So here we have x squared minus 5x minus 24 equals 0. We know it's going to be an x, we know it's going to be an x, and then it's like, what factors of -4 are such that when I add them together, I'm going to get a -5. Well, -24, immediately the factors that stick out in my mind have to do with 8 and 3, because I know that there's a difference of 5 between 8 and 3. So the question is it going to be a +3 and a -8, or is it going to be a +8 and a -3? And it will be a, some of you guys are probably getting this already, it's definitely going to be a -8 and a +3. And the reason for that is because, similar to that kind of rainbow thing that we did before, -8 times this invisible 1 that's in front of the x, or we could just say -8 times x is -8x, plus a +3x, that would give us a -5x. All right, so once again, I think my student's teacher is really big on using this like upside down rainbow method, so that's what I'm going to stick with. And what do we got over here? We got a positive 3. So my student definitely knows that this would be x equals 8 and negative 3 as the answer. Moving on. Last couple problems, we are being asked to use the quadratic formula to solve the last few problems. And the quadratic formula itself is something that most students are sort of expected to memorize. And it is this. And my student actually has done a really good job memorizing this. So there it is right there. I might have to erase it later, but for now we have it. And it's really important to recognize, all right, well, you know, I see a B and an A and a C and all that crap. So it's like, what does that even represent? Well, what it represents is the coefficients that would hypothetically be in front of or associated with the terms of a quadratic formula trinomial or quadratic equation trinomial like this, where A would always be the coefficient that's in front of the x squared, B would always be the coefficient that's in front of the dx, and C would be that constant that's just hanging out minding its own business. All right, so that is the quadratic formula right there. Let's look at one of the problems. So here's one of the problems. We've got 2x squared minus 5x plus 1 equals 0. And clearly our A is 2, our B is negative 1, and our C is that. Now, I am a big fan, when using the quadratic formula, I'm a big fan of writing the quadratic formula, but drawing empty parentheses where the letters go. And this is a really great way of just staying super organized with it and not making careless mistakes when it comes to the like negative numbers. All right, so we're going to put our A and B where it belongs. So we'll start with A. So 2 belongs here and here. B, we have negative 5 right here, and we have negative 5 right here, and then we've got C, which goes right here. So showcasing the value of using parentheses, focusing right here, notice how it was a negative, and then we had to plug in a negative 5 here. That's why I like the empty parentheses approach, because you know it's going to be a negative B over here, right? So it's like negative empty parentheses, and then we just put in our B. Our B is negative 5. And the reason why that's good is because now we can very clearly see that it is a negative 5, which will, on the next line, be a positive 5. All right, so those of you who are experienced with this stuff definitely understand the value of keeping it clean like that, where you can clearly see, not make careless mistakes. So we got x equals positive 5 plus minus, and we've got a 25. So it's definitely a 25 due to the negative 5 squared. This could get a little bit tricky. My student and I discussed probably the least confusing way to go about this is to just kind of multiply straight across. It's a negative 4 times a 2 times a 1. So that would be a negative 8. So actually you just write negative 8 right there. All right, and it will end up being a subtraction situation, but you just write negative 4 times 2 times 1. That gives you a negative 8. So you just write a negative 8 right there. All right. Then put it all over 4, and let's see where this goes. Oh, of course that happens. That always happens. I don't understand this app sometimes. I gotta be honest. It's kind of weird. Like, why would that separate? So here we are, and let's simplify this one more time by calling it x equals 5 plus or minus 25. That's radical 17, and everything's over 4, and that's actually the answer right there. I think the teacher would probably be happy with this. You could split it into 5 over 4 plus minus radical 17 over 4, but it's okay to just have like one single denominator with this like upside down triangle type answer. I think that should be fine. All right, moving on to the next problem. So what we have in the next problem is 3x squared plus 2x minus 4. Now I'm going to assume you guys kind of know the quadratic formula by now. So I'm just going to write this. Notice the empty parentheses, of course. And guess what I'm going to do? Just going to put in what belongs there. I always think of B as the star of the show when it comes to this. 3 is right there. I guess A could be the star too. And then we have that. Right, let's figure this out. We got -2 plus minus. Well, what's going on in here? We got a 4. Once again, -4 times 3 times -4. Well, that would be a positive 48. So we're just going to write that. Just going to write positive 48 to avoid confusion, and then we're going to move on with our lives. We end up with 6 right there. We'll see if the app separated. Well, look at that. Didn't separate the denominator this time. And then we end up with -2 plus minus, what would that be? 52 over 6. Cool. 52. Let's see. Not divisible by 3. Let's see what the factors of 52 are right here. 2 times 26. And that would be 2 times 13. Huh. So we actually have 2 squared present. So what that means is 2. My student actually knows how to do this, which is really cool. Actually, you can extract that 2 out, and it leaves this poor bastard 13 behind, and then we have 6 right there. It's possible that the teacher will be happy with that as an answer, but it's possible that the teacher might also want us to sort of reduce the -2 over 6 and the positive 2 over 6. Without getting into a whole lesson about how to do that, just know that this and this both could reduce with that, where this would become a -1, this would become a +1, and the negative, by the way, is right here, and this would, 6 down here, would become a 3. So that would be, what, -1 plus minus radical 13 all over 3. That is the answer. All right, one more problem. And the next problem is this. -2x squared minus 6x plus 1 equals 0. Quadratic equation would have us write this. And then 2 times that. Okay, filling it in. What belongs here? Well, that would be -6, -6, -2, and 1. And then we got a -2 right there. And working it out right here, let's see, x would equal +6, right? Because -6, thank God for the parentheses, plus minus 36. Okay, being very careful here. -4 times -2 times 1. -4 times -2 is a +8 times 1 is a +8. So, just gonna write that. All over -4. Okay. Then, alright, then we end up with x equals 6 plus minus 36 plus 8 is 44. I see a perfect square in there, and then we have -4. Alright, so we're going to work this out up here. The radical 44, that turns into 2 radical 11. I'm going to hope that the people watching this video sort of understand how to simplify radicals. So that would be 2 radical 11 all over -4. Now, once again, the teacher might be cool with this. I'm sure the teacher would even breathe a sigh of relief that you got this far. But you could reduce the 6 and the -4 and the 2 and the -4, because 6 and -4 are both divisible by 2, and 2 and -4 are both divisible by 2. So this would become a 3, that would become a 2, and this divided by 2 becomes a 1. That's kind of weird. Let's not worry about it, because once again, I do believe you will get credit, and I don't have time, literally, right now to get into why it works out that way. But here we go. That is the answer to this problem. We got 3 plus minus radical 11 negative 2. So I'm really hoping I didn't make any careless mistakes here. It's possible that I did. I actually have a tutoring client coming up right now, and I am parked on the side of the road awkwardly making this video. But hope that was helpful for anyone who could benefit from it. This has to do, once again, with quadratic equations and solving by various means.